Hey guys, welcome back to chapter 15. What we're going to talk about today is different types of equilibria. So what we have looked at so far are the easy examples. So all of the states for those equilibriums have been either a gas or an aqueous solution. What we're going to introduce now is equilibria that have something other than just gas or aqueous and how that affects things. Okay. So first, homogeneous or homogeneous is going to be reactants and products that are all in the same phase. So they're all gas, or they're all aqueous, or they're all solid. So that's going to be a homogeneous. Heterogeneous is going to be equilibria involving different phases. So reactants may be in gas, products may be aqueous, or one reactant's a gas and one reactant's a solid, something like that. So heterogeneous is going to be there's different states or phases involved. It's going to be important that we take note of what state they are in before we write the equilibrium constant K. So one of the things to note here is that the state will always be given right after the formula. So here I see calcium carbonate, and then I see an S. This S tells me that it's in the solid state. It's a solid chunk of calcium carbonate. This is This is carbon dioxide. And carbon dioxide is a gas, so that's why it's got a G here. And this is calcium oxide, and it's a solid. So it's important for us to note the state because some states affect the equilibrium constant and some states do not, or phases do not. So it's important that we know the difference so we can correctly write the formula. The concentration of a solid or a concentration of a liquid does not change and therefore is not included in the equilibrium constant K. So when we write the equilibrium constant, right, we're looking at the concentration of reactants, concentration of products. Does a solid have a concentration associated with it? No, we don't talk about the molarity or molality of a solid, right? Same thing for a liquid. So if we've got a pure liquid, so don't think water in this case, think ethanol, for example. We don't think about the molarity of ethanol, right? We don't think about the molarity of acetone. So solids and liquids are not included in the equilibrium expressions. So the only things that we include are gases and aqueous. So when you get to a problem on a quiz or you get to a problem on an exam and Miss Mazz says, please give me the equilibrium constant K for this equation. And you're like, wow, that's really, really easy. Those are free points. Woohoo! Beware. If it's too good to be true, it probably is not true. So what I'm probably asking in that case, if that's all I'm asking about is the K value, I'm probably going to be asking about this idea of a heterogeneous equilibria. So what I'm going to be looking for is that you leave out liquids and you leave out solids. So that is just your fair warning. So how would I write the equilibrium constant K for this expression? Okay. So K, remember, is concentration of products over concentration of reactants. When I look at my products, I've got two products. I've got carbon dioxide, and that's a gas, so that absolutely gets included. And then I've got this calcium oxide, but that's a solid, so it does not get included. And if it makes your brain feel better, you can put the number 1 there, just so you're like, okay, I've taken account for this, but it's not going to affect the equilibria. And then we take the concentration of our reactants, and again, calcium carbonate is a solid. So that is not going to be included. And again, you can put the number 1 there just to help it make sense in your brain. Whoops. You're with me. I went way back. All right. So to clean this up, anything times 1 divided by 1 is not going to affect that problem. So the K value for this equation is just the concentration of CO2. That's it. That's all it is. Okay. That's what this tells us right here. Why don't you guys go ahead and pause the video and see if you guys can write the equilibrium expressions for the following reactions. All right, so first thing to point out is which ones are not included. So here I see a solid, I'm not going to include that. Here I see a solid, I'm not going to include that. So what's left? K equals concentration of products, so CO2, divided by concentration of reactants, so CO. That's it. That's the expression. All right, for the second one, I see solid. That is not included. I see aqueous and aqueous. So those, of course, are included. So KC for this one is just going to be concentration of products. So Fe3 plus times OH minus. Don't forget to cube that. And then for our reactants, we don't have any reactants, so we could just put 1, or you could just leave it like that, either way. Okay, so that's it for that one. So that's it for K. What we're going to do now is we're going to move into what if it's not at equilibrium yet? What does that mean? And then after that, we are going to start working some problems. I hope you guys found this helpful.